Okay, hello everyone, and welcome to today's Friday Math Happy Hour. Today we're going to cover trigonometric graphs. Okay, this is a trigonometric graph, right? So we're going to graph the sine, cosine, tangent, cotangent, secant, and cosecant. Again, these are the main objectives for today. Graph sines and cosine functions. Graph other trigonometric functions such as tangent, cotangent, cosecant, and secant. Okay, guys, this presentation will focus more on the sine and cosine because the cosecant and secant, you have to graph the sine and cosine before we can do cosecant and secant. Okay, so more than half of this presentation will focus on sine and cosine. Okay, now this is like a normal sine wave, sine graph. Okay, this is one period, and going from negative 2 pi to 2 pi will be 2 periods. And also, guys, here is the amplitude, which is from negative 1 to 1. And right now, I'm going to show you why this is the prior graph of the prior function of the sine wave. So for that, we have to know, right, certain things. We have to know what the A is, which is the amplitude, and what the B is. The B determines the period, which is 2 pi over B. Okay, and we also have to know there's 5 key points to graph one period. So today, guys, we're going to focus only on one period. Okay, but I believe on your web assignments, they want you to do 2 periods. Okay, but once you know how to graph one period, you'll be able to do the other period, which will be the total of 2 periods. For example, here, these are the 5 key points that I was talking about. There's a first point, which is 0, 0. Then comes the second point, which is pi over 2, 1. And then comes the third point, which is pi, 0. Then comes the fourth point, which is 3 pi over 2, negative 1. And finally, the last point will be 2 pi, 0. You see, so here are your 5 key points. Then to graph 2 periods, right? It goes in the same motion, right? It's going to go down first, right? So it's going to be negative pi over 2, negative 1, and then negative pi 0, and then negative 3 pi over 2, 1, and finally negative 2 pi 0. You see, so this is your pattern. It goes like that, and that's your sine wave. Okay, so let's graph it, guys. Let's see why and how we graph the sine wave, which was on the previous slide. Okay, so right, my A is 1 because, right, there's no number there, so there's like a 1 there. So my A is 1, and my B is also 1 because it's like 1x. So we know what the amplitude is, right? The amplitude is 1, and the period will be 2 pi over B, which will be 2 pi over 1. So it's 2 pi. Now we need to find the 5 key points to graph one period, right? So to find the 5 key points, right, we start at 0, but then we divide the period by 4 to get the other 4 points. So the period is 2 pi, so 2 pi over 4 will give us pi over 2. That means that we're going to count by pi over 2. So we start with 0, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, right? These are my 5 points, 1, 2, 3, 4, 5. So now we go back and simplify. The 0 stays how it is. The pi over 2 cannot be simplified, so it stays how it is. The 2 pi over 2 will give us pi. The 3 pi over 2 will give us 3 pi over 2. And the 4 pi over 2 will give us 2 pi. Now, the last point has to match the period, right? You see, it matches. If it doesn't match, it means that you did something wrong here at the bottom. You see, so that's a key factor how you can check that you get in the 5 points correct. Okay. Now, why is this crucial? The graphs are based on the unit circle. Okay, they're based on the unit circle. So the x and the y, right? The x is the cosine and the y is the sine. So, right, so we start here, right, with point 1. What's the sign of 0? The sign of 0 will be 0. That's why at 0 is 0. The second point, what's the sign of pi over 2? The sign is 1 at pi over 2. That's why the next one will be pi over 2, 1. Now, what's the sign at pi? At pi, the sign is 0. That's what's going to be pi. 0 will be a third point. Then the fourth point will be 3 pi over 2. And the sign of 3 pi over 2 is negative 1. So it's going to be 3 pi over 2, negative 1. And finally, right, at 2 pi, the sign of 2 pi will be 0. So it's going to be 2 pi, 0. And there's my graph. There's one period. You see, here's my amplitude from negative 1 to 1. My first point is 0, 0. My second point is pi over 2, 1. My third point is pi 0. My fourth point is 3 pi over 2, negative 1. And my fifth point is 2 pi 0. Right? There's one period. Okay? Now, not every time is I mean the numbers here, right? Like for example, the A is 1 and the B is 1, right? That's real simple to get. But at times we get some crazy numbers. I mean, like this one here. Okay? So we follow the same concept as what we did earlier. Okay, so my A is 1/4, right? I mean the absolute value of 1/4 is 1/4. My B is 1/6. So the B is used to find your period. The period will be 2 pi over B, which will be 2 pi over 1/6, right? So this simplifies to 2 pi times 6 over 1. Because when you have a fraction over a fraction, right, or a whole number over a fraction, the first fraction or the first whole number stays how it is. The division becomes multiplication, and the second fraction, you use a reciprocal, so you flip it. This gives us 12 pi. Now we need the 5 key points, right? So the 5 key points, right, we're going to divide the period by 4, which would be 2 pi over 4. I mean 12 pi over 4, I'm sorry. So we're going to count by 3 pi. So we start with 0, 3 pi, 6 pi, 9 pi, and 12 pi. Again, you see it matches, right? My last point matches with the period, so I know it's correct. Okay, now, because for the sine waves, guys, these are the 5 key points, right? With a pairing graph. I mean, from the previous slide, it's going to be 0, 0, pi over 2 amplitude, pi 0, 3 pi over 2 negative amplitude, and 2 pi 0. But now, guys, since right, these are like the x values. But now these values we cannot use them no more because these are going to be my x values: the 0, the 3 pi, 6 pi over 6, 9 pi, and 12 pi. So I'm going to replace all these x values with the ones we hit at the bottom. Okay. So my first point will be 0, 0. My second point is going to be 3 pi over 2 amplitude. What's my amplitude? 1/4. The third point is going to be pi, right? But it's going to be 6 pi, 0. My fourth point will be 9 pi, negative amplitude, will be 9/4, negative 9 pi, negative 1/4. And my last point is going to be 12 pi, 0. Those are my 5 key points. Guys, and here, guys, we're not going to graph it because here it's saying just finding the 5 key points to sketch one period. Okay, but if we graph it, it will look similar to the graph in the previous slide. But the only difference, all the x values are going to be 0, 3 pi, 6 pi, 9 pi, and 12 pi. And for the y value, it's going to be 0, 1/4, 0, negative 1/4, and 0. Okay? Now, this graph, what happens when you have y equals to negative sine of x? Okay, so this is what happens. The amplitude is going to be 1, right? Because the absolute value of negative 1 is 1. And my b is also 1. So my period is 2 pi over b, which will be 2 pi over 1, which will give us 2 pi. Again, to find the 5 key points, we divide the period by 4. So it'll be 2 pi over 2, 2 pi divided by 4, I'm sorry about that, which will give us pi over 2. So we're going to count by pi over 2. We start with 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, right? And then we simplify. This one stays at 0, That one stays at pi over 2. The 2 pi over 2 becomes pi. The 3 pi over 2 stays how it is. And the 4 pi over 2 becomes 2 pi. You see, again, right, it matches the period, right? The last point matches the period. So I know this is correct. Now to graph it, again, we go back to the circle, right? The x is the cosine, the y is the sine. So at 0, right, at 0, the y becomes 4.0. At 0, my sine is 0. Now, at pi over 2, all right, at pi over 2, my sine is 1. But why is it negative 1? Because the negative here at the beginning, guys, like negative 1 times 1 will give you the negative 1. That's why this is negative. The third point is going to be 3 pi over 2. Pi, it's going to be pi 0. The fourth one is going to be 3 pi over 2, 1. But here it's negative 1, right? But negative times a negative will give you the positive 1. And my fifth point will be 2 pi 0. Now for the graph, you see the graph is going to start going down. Okay, but anyway, guys, this is like a heads up. If the graph starts with a negative, like negative sign, it's going to reflect on the x-axis. So instead of going up, like the original one, it's going to come down. Right? But I just showed you how to find the values here, guys. By doing like the mathematical work. Okay? So now, my first point is 0, 0. My second point is pi over 2, negative 1. My third point is pi 0. My fourth point is 3 pi over 2, 1. And my fifth point is 2 pi 0. So that's my graph. Okay, now, because the sine wave, it just keeps going, forever and ever. You see it just keeps going. For example, right, this is my pi over 2 here. This is going to be my 3 pi over 2. This will be 5 pi over 2 and 7 pi over 2. Same thing going on, right, and it just continues. Same thing going on the left direction. There will be negative pi over 2. This will be negative 3 pi over 2 and negative 5 pi over 2. Okay? And again, right, these are the two periods that they want you to graph, I believe in WebAssign or in your homework. Okay? They don't want you to go by one. They want you to do two periods, the negative one and the positive one. Right? And this is one period, and the whole thing will be two periods. Okay, now let's graph another one. Sketch y equals to 3 sine of 2x. So my A is 3, and my B is 2. Right? And the amplitude will be 3, and the period will be 2 pi over B. So it's going to be 2 pi over 2, which will give us pi. Okay, now for the 5 key points, we divide the period by 4. So pi divided by 4 will give us pi over 4, which means we're gonna count by pi over 4 starting at 0. So 0, pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Now let's go back and simplify them. The 0 stays at 0. The pi over 4 stays at pi over 4. The 2 pi over 4 becomes pi over 2. The 3 pi over 4 stays at 3 pi over 4. And the 4 pi over 4 becomes pi. So those are my 5 key points. Okay, now, again, right? So my amplitude is going to be from negative 3 to 3, right? So let's say this is negative 3 at the bottom, and that's 3. So my first point is 0, 0, which will be right here at the corner. My second point is pi over 4 amplitude, which is pi over 4, 3. My third point will be pi over 2, 0. My fourth point will be 3 pi over 4, negative 3. And the last point will be pi 0. You see, guys, the sine wave has the same kind of graph, right? Something like this that goes first from 0, 0, goes to the amplitude, then back to 0, then to negative amplitude, and then to 0. All of them will have the same shape. The only difference is the amplitude. And also the B, right? The B, which here is 2, it can make it it can make it like smaller. I mean, like instead of 2 pi, right? I mean, here is pi. So I guess the bigger this number, the less it's going to be. The less is going to be. The domain, right? Okay, let's move on. Now let's graph y equals to -2 sine of pi over 4. My amplitude is -2, which will be 2. My b is pi over 4. My period will be 2 pi over b, so it's going to be 2 pi over 4, which will be 2 pi times 4 over pi. See, guys, here the pi's cancel. It's 1, so 2 times 4 is 8. So my period is going to be 8. So for the 5 key points, we divide the period, which is 8, by 4, which will give us 2, which means we start at 0 and we count by 2s. So 2, 4, 6, 8. Okay? So now, my first one will be 0, 0. My second one will be 2, right? It's going to be 2 amplitude. I mean, it's going to be negative amplitude because it's going down, right? Because this is negative. So it'll be 2 negative amplitude, which will be 2 negative 2. And then 4, 0. Then comes 6 amplitude, because it's going to be the opposite, because in reality, this should have been negative amplitude because it's negative here. It'll be positive amplitude, which will be 2, 6, 2. And then finally, 8, 0. Right? Here's my 2, 4, 6, 8. Here's my first point, 0, 0. Then 2, negative 2. Then 4, 0. Then 6, 2. And 8, 0. Now comes the cosine wave. As you notice, they seem kind of similar, right? The cosine and the sine, but the sine starts at the amplitude and it goes down, and then up, and right, it starts at the amplitude and it goes down and then goes up and so forth. The sine starts at 0, 0. Okay, again, this is the same concept. This will be 2. This will be 1 period, and up to here will be 2 periods. And choose my amplitude. And again, we need to find the A, right? Which is the amplitude. And the period will be 2 pi over b. That's my period. So it's going to be the same process as what we've been doing with a sine wave. And the 5 key points, we divide the period by 4, right? Again, this is my point. And then pi -1, and then 3 pi 0, 3 pi over 2, 0, and 2 pi 1. Okay, now let's graph the parent function of the sine. Of the cosine. So again, we start like we did earlier. The amplitude is 1. My b is 1. So the period is 2 pi over b, which would be 2 pi over 1, which would be 2 pi. For the 5 key points, divide the period by 4. Pi will be pi over 2. So this becomes 0, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Let's go back and simplify them. It will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these are my 5 key points. Key points for the x values. Right now, hey guys, right at 0, right, because my first point 0. At 0, my cosine is 1. At pi over 2, my cosine is 0. At pi, my cosine is -1. At 3 pi over 2, my cosine is 0. At 2 pi, my cosine is 1. Now here's my graph, right? There's the amplitude, -1 to 1. There's my first point, 0, 1. My second point, pi over 2, 0. My third point, it'll be pi -1. My fourth point will be 3 pi over 2, 0. And my fifth point will be 2 pi, 1. Okay. Now we have, because here, guys, they don't want us to graph it, just finding the 5 key points to sketch one period. They give us y equals to negative 3/5, cosine of pi over 12, x. Right, so my amplitude will be 3/5. Because remember, guys, since this is negative, right, instead of starting at the top, but the amplitude is going to start at the negative amplitude, right, because it's negative. My b is pi over 12. My period will be 2 pi over b, which will be 2 pi over pi over 12, which will be 2 pi times 12 pi, right? The pi divided by pi will be 1, so they cancel. So we have 2 times 12 is 24. So for the 5 key points, right, we divide the period by 4, which would be 24 divided by 4, which means we're going to count by sixes. So we start with 0, 6, 12, 18, and 24. And again, I know this is correct because the period, which is 24, matches the last x value of the point, 24. Okay, now got my points. Okay, now, because for the cosine, these are the 5 key points. 0 amplitude, pi over 2, 0, right, and so forth. So it goes amplitude, right? I mean, after we get the values, which is a 0, 6, 12, 18, 24, is going to be amplitude, 0, negative amplitude, 0, amplitude. But since this is negative at the beginning, then these will switch places. So it's going to be 0, negative amplitude, which would be 0, negative 3/5. And then 6 will be 6, 0. And then it's going to be 12 amplitude, which will be the positive amplitude, which will be 3/5. And then 18, 0. And 24, negative amplitude. So those are my 5 key points. Okay. Now let's graph y equals to negative cosine of x. How does a graph look like? Here we go again. Same thing as before. Right, so again, right, because it's negative, right? The amplitude will be 1, but since it's negative, it's going to start at the negative amplitude. So the period will be 2 pi over b will be 2 pi over 1, which will be 2 pi. Right? Divide the period by 4, we get pi over 2. So we count by pi over 2. 0, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And these can be simplified. The 2 pi over 2 becomes pi, and the 4 pi over 2 becomes 2 pi. Okay. Again, going back to the circle. Right, so my first point, right, the cosine of 0 is going to be 1. But because this is negative, right, at the beginning, it's going to be negative 1. At pi over 2, at pi over 2 is going to be 0, right? At pi is going to be, right, is negative 1, but negative times a negative, will become positive. So it'll be 1. At 3 pi over 2 is going to be 0. And at 2 pi is going to be negative 1, right? Again, because this is 1, right? But 1 times negative 1 here at the beginning will give us the negative 1. And you see the graph starts at the bottom. Instead of starting at the positive amplitude, it's just at the negative amplitude because the negative here at the beginning, the negative cosine of x. There's my there's my amplitude, pi over 2, pi, 3 pi over 2, and 2 pi. Right, so this is my first point, 0, negative 1, pi over 2, 0, pi 1, 3 pi over 2, 0, and 2 pi, negative 1. See, that's how you graph it. Okay, now comes the translation of sine and cosine curves. Okay, now, hey guys, this here means, guys, that it's going to translate, it's going to be a horizontal shift, either to the right or to the left. Okay, but to make sure, it's better to find the left endpoint and the right endpoint. the left-hand point, you get the bx minus c, and let it equal to 0. In other words, you get what's here in parentheses, and you let it equal to 0 to find the left-hand point. To find the right-hand point, you take the bx minus c, right, and let it equal to 2 pi. But first, guys, we're going to graph it like we've done before. And then we'll apply the translations or the shifts later. Okay, here we go. So my A is 1, right? My A is 1. There's like a 1 there. And my B is 4. So my period will be 2 pi over B will be 2 pi over 4, which will give us pi over 2. So to get the 5 key points, right, we divide the period by 4. It's going to give us, right, it's going to give us pi over 8. So then we're going to count by 8. We start with 0, then pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. Let's go back and simplify. This stays at 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. You see, guys, it matches again, right? The period matches the last point of the 5 key points. Okay, now, again, right, because this is cosine, right? This is the 5 key point for the cosine. You start at 0 amplitude, pi over 2, 0, right, and so forth. But these, the 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2 are going to replace the x values on the 5 key points. Okay. So it's going to be 0, 1, right? It's going to be 0 amplitude. It's going to be 0, 1. It's going to be pi over 8, 0. Then pi over 4, negative amplitude, which will be negative 1. Then 3 pi over 8, 0. And then comes pi over 2, positive amplitude, which will be positive 1. So it'll be pi over 2, 1. Those are my 5 key points. Now we're going to apply the shift, right? But I think we're going to go to the next slide because I won't have any space here. Okay, so again, I kept the 5 key points. Now comes, let's find the left-hand point, right, and the right-hand point. Right, the left-hand point, we let the 4x minus pi equal to 0. So we add pi to both sides, so 4x equals to pi. We divide by 4, so the left-hand point starts at pi over 4. Now for the right-hand point, you take the bx minus c, right, which would be the 4x minus pi, that equal to 2 pi. We add pi to both sides, so we have 4x equals to 3 pi. Divide both sides by 4 will give us x equals to 3 pi over 4. So the graph is going to shift pi 4 units to the right. Okay, here's how you do it then. We can add pi over 4 to every x value. So to every x value on the 5 key points, we're going to add pi over 4. And why? Because the original one starts at 0, right? But according to here, the left-hand point should start at pi over 4, which means that I have to add pi over 4 to every x value on the 5 key points. So it'll be 0 plus pi over 4, 1, which will give us pi over 4, 1. That's my first point. Then comes pi over 8 plus pi over 4, right? And the 0 and the amplitude stays the same, will be 0. So it's going to give us 3, I believe it's 3 pi over 8, 0. Then I'm going to add pi over 4 to the pi over 4, which will give us pi over 2. Pi over 2, negative 1. Then at the 3 pi over 8, I'm going to add pi over 4. So it's going to give us 5 pi over 8, 0. Then finally, we can add pi over 4 to the pi over 2. So it's going to give us 3 pi over 4, 1. As you notice, all the y values, they stay the same. Because if it's going to shift horizontally, it means the x values, are the ones that are going to change. So these are my 5 key points here. Okay, now, here's my graph. Okay, guys, why is a graph like this, right? It seems like it feels like the sine wave, but this is a cosine wave. It's because everything shifted by 4 units to the right, which means, right, this will be the amplitude, 1, negative 1. And my first point, right, the graph is going to be cut, is going to be from here to pi over 4, right, to here, to the 3 pi over 4. Right, there's my pi over 4, 3 pi over 8, pi over 2. Then comes my 5 pi over 8 and my 3 pi over 4. Again, the graph will be cut from this point, the pi over 4, to the 3 pi over 4. That's going to be one period. But you want to grab more period, more like another period, all you do is continue in the same motion as a positive one. I just go like this, up and down. Now here comes my point. It'll be the first point is pi over 4, 1. Then comes 3 pi over 8, 0, which would be this one here. Then comes pi over 2, negative 1. Then comes 5 pi over 8, 0. And finally, 3 pi over 4, 1. Again, so again, it goes from here, from the first point there, to the last one here, to the 3 pi over 4. That's your graph. Now what happens if you're going to do also a horizontal shift plus a vertical shift? What do we do now? So let's do the very same one as before, the y equals to cosine of 4x minus pi, but now we're going to add 3. What does the 3 mean? Okay, it just means, right, so we go back from the previous slide, right? These were my points for the horizontal shift, but now with the d, guys, this means it's going to be a vertical shift, which means I'm going to add 3 to every y value. So it'll be pi over 4, 1 plus 3, which will be 4. It'll be 3 pi over 8, 0 plus 3 will give us 3. It'll be pi over 2, negative 1 plus 3 will give us 2. Pi over 2, 2. 5 pi over 8, 0, 0 plus 3 will give us 3, so it'll be 5 pi over 8, 3. Then finally, we have 3 pi over 4, 1, so we're going to add 3 to the 1. It's going to give us 3 pi over 4, 4. Okay, now I'm going to go to the next slide and show you how they shift, right? This was the one from before. Now with a plus 3, it means that all these points are going to go up 3. Okay. You see this one, it went up 1, 2, 3. The pi over 4 went up 1, 2, 3. The 3 pi over 8 went up 3, 1, 2, 3. The pi over 2, right, it went up 1, 2, 3. The 5 pi over 8 went up 3, 2, 3. And finally, the 3 pi over 4 went up 3. 1, 2, 3. Does anybody have any questions? Okay, let me move on. Okay, there's my amplitude. Went up 3. That's other than 4. Okay, now guys, now comes, we're done with that was from section 4.5. What we did, guys, we graphed the sine and cosine. Now we're going to graph tangent and cotangent. Okay. Here are the rules for the tangent. The period is going to be pi. Okay, so every period, right, is going to be pi. It's going to be like from negative pi over 2 to pi over 2. You see that? That's one period. From pi over 2 to 3 pi over 2 is another period. What that means that the domain is all the x's, right, except at pi over 2. At pi over 2 is going to be asymptotes. Every pi over 2. Now the x-intercept is going to be n pi 0. The y-intercept is going to be 0, 0. And symmetric is going to be, the symmetry is going to be origin symmetry, and the function is odd. Okay, now, so how do we graph that? Okay, the tangent of theta is y over x, which is the y value over the x value. Okay, so at pi over 2, right? At pi over 2 here, at pi over 2, it's going to be 0, 1, right? So what's 1? Right, it's the y over x, so 1 divided by 0 is undefined. Because that's why at every pi over 2, it's undefined, right? That's why you have those vertical asymptotes. See, undefined. That's why it says here that every pi over 2, every x equals to pi over 2 plus n pi is undefined. Again, every pi over 2 is undefined. So if we keep adding pi, all these will be vertical asymptotes. Again, most of the time they want you to graph 2 consecutive vertical asymptotes, which would be like, for example, 2 of them, will be something like from say negative pi over 2 to 3 pi over 2, right? That's 1, that's 2. Okay, now, so to get the two vertical asymptotes, right, it's going to be bx minus c equals negative pi over 2, and bx minus c equals to pi over 2. The two consecutive vertical asymptotes. Okay, now, let's graph the sketch. Example 1, sketch a graph of y equals to tan of x over 2. Right, so we're gonna have to, get the left, asymptote, which would be bx minus c equals negative pi over 2. So it will be x over 2 is gonna be x over 2 equals to negative pi over 2. Right? We multiply both sides by 2 to get rid of the 2 here at the bottom. So x equals to negative pi. And over here, guys, we have x over 2 equals to pi over 2. So we multiply both sides by 2. It's gonna give us pi. So these are two consecutive vertical asymptotes. Okay. Now, you see, guys, and here my graph. You see here because there was a x over 2 there, it wasn't just x. So this one, it's going to be like, instead of being every pi over 2, now it's going to be pi, right? And here it tells us that for two consecutive asymptotes, it's going to be every pi instead of pi over 2. So the number here, guys, the bx, it does matter, right? Because instead of being every pi over 2, it's going to be every pi. You see, so at every pi, there's an asymptote. Okay, now, you see here, guys. Here's saying that x over 2, right? So let's do this. At every pi is going to be undefined. Here's why, guys, because we're going to plug in negative pi over 2. For the 2 is right here here. It's going to be negative pi over 2 over 2. Right, so it will give us tangent of negative pi over 4. Right, so negative pi over 4 is going to give us what? Negative 1, which means at negative pi over 2, which will be here, guys, is going to be negative 1. Here's where you find the curve. Right, because this is negative pi over 4. This will be negative pi over 2. This will give us 0. This will be pi over 2. So then, right, now let's do the 0. At 0, 0 over 2 is going to give us 0. That's where the point comes in here. Because the tangent of 0 is going to be 0, right, which will be the point here. And then at pi over 2, which will be this point here, pi over 2, we plug in the tangent of pi over 2 over 2. So it's going to give us tangent of pi over 4. The tangent of pi over 4 is going to give us 1. You see, that's where the 1 comes in here. And this is your graph. That's how you graph it. Okay. Now let's sketch the graph of y equals to negative 3 tangent of 2x. Okay. So bx minus c equals to negative pi over 2 for the two consecutive asymptotes, and bx minus c equals to pi over 2. So it's going to be 2x equals to negative pi over 2. Again, here we divide both sides by 2, so it's going to give us negative pi over 4. And bx minus c, right, which will give us the 2x equals to 2 pi. We divide both sides by 2, or multiply both sides by 1/2. It's the same thing. So it's going to give us x equals to pi over 4. So these are my two consecutive asymptotes. Okay, now, as you guys, right? So instead of going like this, guys, like starting high and coming low, it's going to go the opposite. Why? Because of the negative 3. Okay? So here's how we get it. We're going to plug in, let me go back. Right? You're going to plug in the values here, guys. For example, negative pi over 4, you're going to plug it in here. So it'll be 2 times, the tangent of 2 times negative pi over 4 is going to give us negative pi over 2. And that'll be undefined because every pi over 2 is undefined. Right? And then we keep plugging the negative pi over 8. So we plug it in here. Right in here at the 2x, it'll be 2 times negative pi over 8 will give us negative pi over 4. Right? Negative pi over 4 is going to be negative 1. Then when you multiply it by negative 3, it's going to give us a positive 3. Where is it at? Negative pi over 4. Right? Negative pi over 8 is going to be a positive 3, so it'll be about right there. And we keep plugging all these values here where the 2x is, where the x is. That's where all the points come from, all these points here. Okay, so this is one period here from negative pi over 4 to pi over 4, because that's what we got here for two consecutive asymptotes. Now comes the graph of the cotangent. If you notice, the cotangent goes in the opposite way as a tangent does. It starts high and it keeps going low. On the tangent, it starts low and it keeps going high. Okay? So for the tangent, the period is going to be pi. So for the tangent, at every pi, they're going to be asymptotes. You see every pi. They're going to be asymptotes, vertical asymptotes. And this one is the symmetry is origin symmetry is also an odd function. Because other functions, for example, only the cosine and the cosine and the secant are even functions. And the tangent, cotangent, sine, and cosecant are odd functions. But that's another story, guys. I don't want to jump into that because that's a little bit more challenging, guys. And I believe that we did those. That's from section 4.2 or 4.3. Okay. But just know that the tangent and cotangent are considered odd functions. There's my inner circle. Here's why at every pi it's undefined or vertical asymptotes. The cotangent is x over y, right? So at pi, right? At pi we have -1, 0, and the cotangent is x over y, so it's going to be x, which would be -1 over 0, which would be undefined. That's the reason why that at every pi there's asymptotes, because at every pi it's undefined. Okay, that's what that means right there, x equals to n pi, which would be the vertical asymptotes. Now for two consecutive vertical asymptotes, to find two of these, right, two vertical asymptotes, here's what you do. It will be bx minus c equals to 0, and bx minus c equals to pi, right? Because remember, for the tangent, it was bx minus c equals to -pi/2, and bx minus c equals to pi/2. But here's it's different. Here's from 0 to pi. Sketch a graph of two cotangent of x over 3. So we're going to get the x over 3, right, equals to 0, and x over 3 equals to pi. So here on the left, guys, we multiply both sides by 3, so x equals 0. Here, with a bx minus c equals pi, it will be x over 3 equals to pi. We multiply both sides by 3, so it's going to give us 3 pi. So this will be one consecutive asymptote, vertical asymptotes. Okay, you see, guys, so every okay, from 0, right, to 3 pi, so every 3 pi, you see there's vertical asymptotes going to the right, to the positive, and also to the negative. So again, every 3 pi, there's vertical asymptotes. And again, right, we do the same process as before, right? At 0 and at pi, it's undefined, right? Because at 0 and pi, there's asymptotes. So if we plug here 3 pi over 4, right? I believe 3 pi over 4 is going to give us, let me go back. It's going to give us 1. 3 pi over 4 divided by 3 will give us 1, and 1 times 2 will give us 2, right? And then we plug here 3 pi over 2 is going to give us 0. 0 times 2 will give us 0. And that 9 pi over 4 is going to give us -1. -1 times 2 will give us -2. And at 3 pi, it's going to be undefined, right? Because here are my two vertical asymptotes, the 0 and the 3 pi. Now comes graphing the cosecant and the cosecant function. Hey guys, to graph the cosecant function, first you have to graph the sine function. You have to. That's why I spend a lot of time on graphing the sine and the cosine. Because to graph the cosecant, you first have to graph the sine wave. And then every time there's like an x-intercept, right? Right here's an x-intercept, 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 and x-intercept. Those will be, right, like asymptotes, right? So that's what the graph. And how you graph it, then you take out, then you erase the sine wave, and you're left with a cosecant, which are all these in black, like in dark black. Okay. Right. So again, need to sketch the sine curve. Then at every x-intercept, there will be an asymptote. You see what I just mentioned right now. Here we go, guys. So first, to graph the cosecant, first I need to graph the sine wave, right? So again, right? So it's going to be at every at every intercept, there's going to be an asymptote. Right now, right? You see there's every intercept, so there's going to be asymptote there. So then, let me go back. It's because I couldn't find a way to actually graph it, but here, guys, for the cosecant, it's going to be right here. You see, it's going to go like this. It will never touch the asymptotes. It's going to go like this, right there. You see, they're going to like touch each other at the I'm here at the extrema, and then from the negative, it's going to go like this. Touch it there at the negative pi over 2. It's going to come up like this. It's going to touch it there at the pi over 2 at the amplitude. And also here on the right side, it's going to touch it there at the 3 pi over 2 at the negative amplitude. That's where the graph comes from here. You see, I mean, at every extrema is going to touch it and go up. That's what I was trying to describe in the previous slide. Okay. Now, for the secant, it's the same thing, right? But now you're going to have to graph first. First you graph, I mean, the cosine. Right, so remember, guys, this was my cosine graph because the cosine starts at the amplitude. So at every intercept, it's going to be, right, I mean, a vertical asymptote. But here, guys, it's going to be at every pi over 2. I mean, at every pi over 2, right? Also back here at negative 3 pi over 2. And for the secant, again, it's going to go like this, guys. Okay, it's going to go like this, right? It's going to touch at the extrema. It's going to go up like that. You see, it's going to touch again here at the pi. Touch it and come down. You see, that's where this comes from here, from the graphs. Okay, now if you graph y equals to secant of 2x, first you have to graph the y equals to cosine of 2x. Once you graph the cosine of 2x, which I showed you at the first part of this presentation, which was graphing the sine and cosine, then at every intercept, there's going to be some asymptotes, right? And once you I mean do the graph for the cosine, then afterwards all you do is get I mean at every asymptote it's going to go down and touch at the relative extreme there at the maximum value there and go up. See, that's how you do the graph. And then you can erase the one with the dotted line, and what's left will be your secant graph. Okay, you see what you have that on. Now, guys, I know that I went a little bit fast because I have to finish within 50 minutes, and I believe I just finished on time. Okay. Hey, guys, thank you, guys. Let me take it back to the host, so they can tell you more about what's going to happen in the future and future presentations.
Thank you, Mr. Stasi. We won't be doing a closing, sir. There's no participants. It's just faculty and us facilitators. But thank you for your presentation, sir.
Well, thank you, my friend. Thank you very much.
We'll see you next week. Primero Dios.